Welcome back. This time we're going to be solving for an angle when two sides are given. You'll notice that in this example 3, I've got my right triangle. I've got one length here, it's 7 units, another length here which is 25 units, and I would like to solve for angle A. And that's what I'll do, solve angle A, so in degrees. So you just had a lesson probably in class on your sine inverse, tan inverse, cos inverse button. So I'm going to just make an assumption that you know how to do that. Okay, that I'm not going to put that in this video. So we would like to know how many degrees is angle A. Well, just like before, we're going to circle our angle of interest. There's our angle of interest. We don't know it yet. But we are going to name the other two sides relative to this. So we've got that one, that's the opposite. And we've got this one, which is the hypotenuse. So if you take a look at your chart, you'll see that opposite and hypotenuse, they would suggest sine. So we're going to say sine A is equal to the opposite over the hype. And I'm just going to keep going this way for now. In this case, the opposite is 7, and the height is 25. So ultimately then, sine of A is equal to 7 divided by 25, and 7 divided by 25 is 0.28. So 0.28, the calculator knows what ratio or what angle creates that ratio. And we're going to get the calculator to tell us, and we're going to use the sine inverse key. Okay, so this is the notation. We go sine inverse of 0.28. That's how you say it, sine inverse of 0.28. It looks like a multiplication, but it's not really. It's just the notation. Some people say arc sine, but we won't go there. We'll use the phrase sine inverse. Okay, so you can take a look at your calculator. You can plug in sine inverse of 0.28. Now, it's important that you use your own calculator because different calculators are designed to operate with different keystrokes. So on my calculator, I go 0.28, second function, sine, and it'll give me an answer. Maybe on yours you might have to press second function, sine, and then the 0.28. So it's up to you to know your own calculator, okay? So again, I'll go 0.28, second function sine, and I get this long crazy number, 16.26 and so on. And so I'm going to call that 16.26 and so on. And so angle A is approximately equal to 16.3 degrees. Okay, I'm not making an issue of it's 16.3, 16 even. That is not my concern. If you get this far, then I have no concern that you understand this. You follow along fine. Okay? So we'll flip to the next example, example 4. Example 4 is on page 13. So here we have two lengths given again, and wouldn't you know, I forgot to put in my right angle symbol there. There it is. And I'm wanting you to solve for the unknown angle. Well, in this case, I've got this funny looking thing here. Actually, it's a Greek letter. It's the Greek letter theta. And all kinds of Greek letters crop up in science and math. It's not to confuse the issue, it's just that, you know, sometimes they'll use English letters to represent lengths, and they'll use Greek letters to represent unknown angles. If you want to go in and draw another triangle and call that angle B, that's fine, it doesn't matter. But in this case, I chose theta just so that I could introduce you to the symbolism. Okay, so we're trying to solve for theta. Let's circle it. Now this is the 4th triangle that I've done. And you'll notice that every single time, the first thing I did was circle the angle, whether I knew the angle or not. So I circled the angle. And that should be a hint, hopefully that's a hint, that if you want to learn this, why don't you go exactly as I do it. Once you get a little bit more adept at it, you can do whatever you need to do. But for now, why don't you try doing it exactly as I do, and you'll have success. So here's our angle, it's circled. I'm going to go and draw an arrow to one of the sides. That's 12. This is 3.5. This side over here, there's no information about it, so it doesn't apply. So let's name our sides. Well, right across from the angle we have the opposite. And touching the angle we have the adjacent. Now from your first practice set, maybe you're starting to learn what these names are relating to, and now you're maybe getting to know that when you see opposite and adjacent, we're talking about the tan, which is actually short for the word tangent. So let's write that down. We discovered that it's tan. Now it's the tan of theta. You don't just have tan, you have tan of an angle, which means, in this case, it's tan theta. Again, if you wanted to call that a B, that's fine with me. Tan theta is equal to, let's just take a little shortcut here. We're going to go 12 over 3.5. Okay, now 12 over 3.5, I'm quite amazed sometimes that people struggle with what this actually means. It means 12 divided by 3.5. You enter your 12 first. 12 divided by 3.5, and we get a number such as 3.4286. So tan theta is equal to 3.4286. Again, that's rounded to 4 decimal places. So what do we do with this number? By the way, I'll just make another sidestep here. The only trig function that can have a number that's greater than 1 is tan. Sine and cos always have to be less than 1. Always. So we have tan theta is equal to 3.4286. And what we're going to do is we're going to tell the calculator to undo this number and tell us what angle caused this relationship right there. There was an angle that caused that relationship. So we're going to go tan inverse of this number. Now on my calculator, I still have that long, messy number showing, and on some of your calculators you'll have the same thing. And so I'm just going to leave it in there. And I'm going to say second function tan. And then it's going to give me a number. And again, the number is long and messy. But we have to know that when you use the tan inverse, or any inverse function, you're going for an angle. So, the tan inverse of 3.42 and so on is equal to, let's see, I'll write it over here, is equal to 73.73 and so on. What does that mean? It means theta is approximately equal to 73.7 degrees. And again, if you wanted to prove that to yourself, you could go onto a piece of paper, maybe some graph paper or something like that, and draw 3.5 straight across. Centimeters would fit on the page. Inches wouldn't fit on the page, but centimeters would. 3.5 centimeters across, 12 straight down, and then attach the ends of those two lines and then go in and measure your angle. And you're not going to be able to tell that it's 73.7 perhaps, but you will be able to tell that it's somewhere between 73 and 75, which is really all you can do with the equipment that we would use in high school. Okay, so those two examples pretty well complete the basic trig level. And that leads us up to the next practice set. And the next practice set is on page, 14. And it says on page 14, solve for the angle indicated to the nearest tenth. So take some time, you can stop the video, take some time to do that, and then once you've completed page 14, you might want to go over to page 15 where it's a mixed set of practice. Okay? And again, don't forget that the answer key is in the very back page. So, good luck with that, and have a great day.